So we are discussing about the concept of me method. So, so to identify the class level attributes and the method level attributes, so we'll go ahead with the me method. So in this, like we'll be discussing about how do we make use of this me concept in your program. So let us go for that. So I'll go for simple one, class C1, C1 definition in class. Public section. In this, let's discuss about data I. Let's, let's go for N1, type I, value 5, methods say M1, and then we'll go for class C1 implementation in class method M1 and method M1 and method data M1 type I, value 2. Now if you see here, N1 is being declared in N1 is declared in the C1 public section and in the method also. So we have the same N1 is being declared twice. Okay. So it's declared here as a value 5 and here it's declared as value 2. In fact, like we can also declare something else as well, not just integer. We can make it as a character also, and we can rewrite the values. Okay. So now here what we'll do is write me N1 means within the class within that method. Me means that same method, the method M1. Then we have N1. So me N1 and N1. So these two things we are calling in the method. Then startup selection, data data N2 type I, N1 type I, data O1 type ref2 C1, create object O1 for O1. This test method is M. So here, what we are doing is we are calling this N1 N1. So simply to identify between the N1 which is declared in the method and the N1 which is declared in the class, we'll say me N1. Me N1 means the method N1. So whatever the name of the method is, inside that method, me will be that method only. So in this, like we'll get this 2 first, and then we'll get normal n1 that is declared in the classes, and that is 5. This is what we'll have. So 5 and 2. 5 and 2. Actually, m1. So when this is calling m1, it's going here n1 type I value 2, me n1, and then n1. So me n1 is actually calling the class. The class whatever we declared here, that is coming in the me n1. So if I make it as 15 and activate 15 and 2. So first the class me n1 will print the class class definition, and here n1 normal n1 is the method itself. So this is about the definition of a me method. Then we'll go for the pointers concept. We'll understand the use of pointers table. So this is also a very important concept. Pointers. Let's go for the pointers concept. Let's understand the concept of pointers. Let's see one definition in class. Here we have public section, methods, m1, class data, m1, class c1, implementation, method in method, method m1 in method. We have n1 is equals to n1 plus 5. n1 is equals to n1 plus 5. We write n1. Now we'll see the pointers concept. We'll understand the pointer. This is a normal definition, normal implementation. So we just defined one method m1, and we have done the implementation for that. We have done the class data n1 type I. This is what we have done, and we'll go ahead to the next concept. Startup selection, data o1 type ref2 0, o2 type table of. So this is, let's take this as it underscore o1, it underscore o1. We are taking it as a table. We are treating this as table. ot underscore o1, ot underscore o1, ot underscore o1 type table of, type table of, type table of ref2 c1. 2 5 times. Create object O1, append the O1 to IT underscore O1. So we're treating this IT underscore O1 as an internal table and O1 as a work area, and we can do that. And then we'll go ahead with in loop. So then we can go ahead with loop at IT underscore O1 into O1 into, so call method O1 member. So just like just this is the same as the internal table and work area concept, guys. So internal table and work area, this O1 type ref to C1 we are treating it as a work O1 is we are treating as a work area. In IT underscore O1 we are treating it as an internal table. So create object O1, this has to be written every time. So append O1 to IT underscore O1. So when we say create object and append O1 to IT underscore O1, so this values will be appended. Call, so then when we say call method, so how many times it will be created, object will be created 5 times, object will be created and 5 times it will be appended, and 5 times this method gets executed there. So this method gets executed, so 5 times will be done, and first time, so 5 10 15 20 25, so 5 times we have done this create object and append O1 to IT underscore O1. So every time a new record is coming and that is getting updated here. So we'll go for this select. We'll execute this. Let's see what is happening in the backend. We'll go for this O1 IT underscore O1 is also initial. So F5. So create object O1. So create object O1 means some value can be loaded. So IT underscore O1 has nothing in it. O1 has some values. Here in redo. No, first time first record has come. This one. Second time second record will come. Third time third record will come. Fourth time fourth record. Fifth time fifth record. So 5 records have come here. Loop statement. So in the loop statement, again, every time the new record will come here. Similar to the internal table and work area concept. So once you execute, you'll get this 5, 10, 15, 20, 20. These are the values that we have. So this is called table pointers concept, wherein we are assuming the object as a, we are creating an internal table type object, and then we are making use of that, and we are appending the data. Multiple records of values can be appended into it. So it's a very simple concept, simple program to understand the interfaces concept. So we'll go for interfaces, I1, and interface. We'll go for interface actually. Interface, interface. So in the interface, we can declare methods actually. So methods, say M1, M2, these are the methods. So we have this. Now this interface is just like our include program, which can be only used in the, see, include program can be used in the executable program. From there we can make this, but you cannot use the include program directly anywhere. You can only use the include program within the program, and that can be used again in the for executing. Similarly, interface cannot be used individually. It has to be used in the program. It has to be used in a class. Interface needs to be used in the class, and that class can be used again in the program. You cannot use the interface directly in the program. So we'll be consuming this interface in the class C1 definition and class. So we'll go for public section. We'll go for interfaces I1. Now let's try methods M1. Methods M1. So we'll go for class C1 implementation and class method I1 tilt M1 in method. So let's write I am M1 from I1 and M1 from I1. Method I1 tilt into and method write I am M2 from I1 method M1 and method I am M1 from C1, because this is a method which is declared in the class. So if you want to implement the method of the interface, you have to write tilt, so that we can identify that it is a method of the interface. You can have the method with the same name as well, but that would be differentiated like this. So method M1, if you're writing method M1, it is a method of the class. But if you're writing I1 tilt M1, so that is a method of interface. That's what we have. Startup selection, data, O1, type to C1, create object, O1, call method o1 i1 tilt m1 i1 tilt m1 tilt m1. Then we can say call method o1 i1 tilt m2. Then we have call method o1 m1. Okay, we'll write the slash here for all the things. Slash slash slash. So I'm M1 from I1, M2 from I1, M1 from C1. This is the pattern. This is the order in which we are calling. This is the order in which it gets executed. So this is an interface. So once again, you understand that an interface is something which can be used for multiple number of programs. So you can also create an interface in the SE24 global interface also you can create. Let's see how to create a global interface. You just say zdxc underscore if1. So zdxc underscore if1 create. Now it will ask you, do you want to create a class or interface? If you create an interface and then create global interface. So here we can write m1 and we can declare the level instance m1 m2 instance activated. So we have zdxc underscore if1 is the interface. So we can make use of this zdx1 underscore if. This is active now. So in the place of this interface, we can just comment this. So we can go for, instead of this I1, we can write this zdxc underscore if1. zdxc underscore if1. if comment interfaces zdxc underscore I1 if1. And then here we have to go for method zdxc underscore if1 tilde m1 and method, right. So we can call it like this zdxc underscore if1. So in the same way here also we can go for same thing. Now if you don't implement the implementation for M2, it will throw an error because M2 also is a part of the interface. How many methods are there in the interface? That many interfaces, that many methods have to be implemented here. It's mandatory. Go for M2 here. M2. M1 I'm not touching here. Here also we'll call it as call method zdxc underscore if1 tilt m1 call method zdxc underscore if tilt m2. O1. Yeah, O1. We need to give the reference of O1, right? So instead of creating the interface locally, we are creating the interface globally, and then we are making use of that in a program. So that's what we have done. So we can go ahead and create an incident. So whenever you just remember, whenever you are trying to create a class in the incident, it will ask you first, would you like to go for interface or a class? So we'll just discuss a simple program in which we are going to have event in one program and event in one class, and the triggering and the method in the different class events. We go for class C1 definition in class. In this we'll go for the public section, events E1, events E1. Okay, next we'll go for methods N1. This is a triggering method, right? So we'll go for, no, it should be M1. It should be M1 here. Methods M1. Then we have class C1 implementation in class. Here we go for method M1 and method. So in this we'll simply write I am M1 from C1. I am M1 from C1. Raising E1. So I am M1 from C1 raising E1. That's what we'll write here. And then we'll go for C2 implementation. So we just have this. Okay, here we'll go for raise event E1. Raise event E1. Now we'll go for class C2 definition in class method methods. In definition it should always be methods, and then implementation, right? Method. This is a triggering mechanism. Okay, the triggering event. Go for M2 or trigger. I'll go for TM, triggering method. Okay, triggering method TM for event M1, for event E1, for event E1 of C1. The triggering method for event E1 of C1. This is what we have the definition for. This should be in the public section. So we are declaring TM. So we go for class C2 implementation in class method TM and method. So in this we'll this is C2 implementation. Sorry. So TM triggering method TM for event event in class in C1 in class C1 for event in class C2 it's class C2 for event event in C2 in C1. So event, see the basic event we are declaring in the first class. Okay, so we have defined it in first class. Then we are writing the triggering method in the C2. Okay, methods TM for event even of C1. So this is like we can define it. The triggering method we are defining it in different class. That's what is the main concept here. We're declaring the event in one class and calling it in another class. So we'll go for startup selection, startup selection, data, O1, type ref O2, type ref C2, type ref C. Create object, O1, O2. Create object. Okay. This is a common one. Okay. So now let's go for set handler O1 M1 for no O2 O2 M1 no O2 TM O2 TM O2 TM O2 TM for O2 TM for O1. So this is O2 TM. TM is the triggering method for O1, which is an event. The event is in O1, right? So that's it. Now call method O1 M1. So we are having the event in one class and triggering method in the another class. That's the difference. So previously we've done method and event both in the same class. We just did have the slash here. So I'm M1 from C1 raising event. I'm triggering method TM in C2 for event E1 in C1. This is what we have. So what's happening here is we are basically going ahead with the call method M1. So M1, it goes to M1. It it first prints this, then it triggers E1. So when it triggers E1, it goes to the triggering method of E1. The triggering method of E1 is TM. So for the TM, we have this code here. So this is about the event which is defined in one class, and and the and the triggering method is in another case. So let's write a simple program which triggers the standard exception, class exception. So this is a standard exception given by SAP. Okay, so we'll go ahead with since we are not creating anything here, it's a SAP standard, so we'll just directly write the startup selection, and in this we'll go for try and end try and try, and in this we'll write something like perform perform sub underscore check sub underscore check underscore info sub underscore check number using 5. Now 5 is a number, so catch. This one is a SAP standard one. CX. All SAP standard exception classes will start with CX. Okay, anything which started with CX, it's an exception class. Zero divide. Zero divide. And then right. And then we go for. So for this perform, we have to have a form below. So double click on this. And we want to create yes in the main program. Yes. It gets created here. Let me delete this. Basically, in the real time, you're not supposed to delete anything here. Let's delete it. So we'll go for this is p underscore number actually. So here we go for p underscore number. Okay, let me remove this and I delete it again once again because we'll double click on this. This in the main program. So, okay. Then we'll go for p underscore number. Here we'll write raising cx underscore sy underscore zero divide, and here let's go with p underscore p underscore n row is equals to p underscore n row divided by 0. So if this 0 divided by 0 is raised, then automatically this catch cx underscore sy underscore 0 divide is triggered. So uh, now now that we have it like that, so we'd be definitely raising the exception. Okay, so here we'll say, so initially we'll go for divided by 2 p underscore p underscore. So let's say p underscore number is equals to 10. Okay. Just to raise that. To get this right. But now when I go for p underscore n1 divided by 0, the moment I do that, it will catch this cx underscore sy underscore 0 divide. That will be what. So when we execute, hello is been typed. So hello is something which we need to write it as 0. We can write it as something like 0 divide error. We have got that. Okay. So 0 divide error. So we can just activate this, and when we execute this, get 0 divide error. We can also write a message here. Message A001 of 00 0 divide error. So immediately you get 0 divide error. Exit. So we can populate any kind of a error like that. So here what are we trying to understand is, if let's say, if any of the conditions in any of the conditions, if this occurs, if this scenario occurs wherein we have divide by 0, then it should immediately raise this event is what we are doing it. Okay, so in this there is a raise a raise exception concept. So we are just doing this try and try. So we have to always give this raise and catch inside try and try. These three are a combination. Try and try is try and try and catch. So in that catch, below the catch, we have to write the text or whatever it might be. So if this gets triggered, if this catch gets triggered, then what should happen is what we are writing there in the logic. So cx underscore square underscore 0 divide is the event, is the class. So next one is like we'll go ahead with the exception. Okay, so let me again explain this. So what did we just do is we wanted to trigger divide by 0. Okay, for that what we have written, we are writing this try and try. Anywhere in the program you can write try and try. And if let's say there is a code, in that code you have a doubt that you might come across a uh, divide by 0, then you have to write catch. So you might have written the logic here, and then finally you have to write a catch at the bottom. So within the try and try, so we write catch, and then we have the message. So this message gets triggered here. Message will get triggered whenever that try and try will get caught. Okay. Now let's create a exception class locally in our program, and then we'll understand that in a better local. So we're creating a local exception class, and then we'll make use of that in our program. So we have class cx underscore my underscore exception, cx underscore my underscore exception definition, and this. Now you have to write this. We can inherit the properties from a standard class. So we'll go for a global message class. That's a exception class, that cx underscore static underscore check. This is a exception which is basically standard, you know, exception class. In that we'll write. Okay, that's it. Let's keep this like this. Then we also have to go for class cx underscore my underscore exception implementation in class. This is what we have. In this, we'll go ahead with implementation. So implementation, what we'll write is like, we'll keep it blank because we have already inherited the properties from cx underscore static underscore check. So now we'll make use of that in the class, in a normal class, class c1 definition and class method in1 and method raise exception, raise exception type is exception type cx underscore my underscore exception exception ex ref to cx underscore underscore exception one type ref to c1. So we have an exception class cx underscore my exception, which is of type cx static check. Then we have o1 type ref to c1. So of selection. Now we'll go for try and try. and in between we have to have a catch. The catch should be at the end of where we have to check the condition. So in this, like, we'll go for create object, create object o1, and then o1, all this is one. So my exception code. Okay, so here it should accept this actually. Okay, it should be in public section. Okay, this should be in implementation. This should be an implementation part actually. Methods, implementation. Okay, so we'll write this as catch. So we'll have this catch cx underscore my underscore exception into x. This is what we have.